Hello everyone, this is Sindhuja Reddy from Mlritm College at Dundigal. Today I am going to explain about the introduction of finite automata. So, what is finite automata? The finite automata it is used to represent language and the symbols, alphabets, are all those things. So, from this introduction of finite automata, we are going to discuss about the symbols. What is symbols? The symbols is nothing but it is used to collection of objects. Collection of symbols are empty objects. So collection of object is nothing but for example it is the alphabets A, B, C. Collection of objects, any item like alpha numbers, symbols, operations, all those things we can say symbols. So the next terminology is alphabet. So alphabet is a collection of symbols. Alphabet is a collection of symbols. It is denoted with sigma. It is denoted with sigma. So collection of symbols is nothing but any number, letters, all these things. So small s avvachu and the numbers. So it is denoted with sigma. The next terminology is string. The string is nothing but it is the collection of alphabet. Collection of alphabet. So it is denoted with W. It is denoted with W. So the string is nothing but we can write with the by using alphabets. By using alphabets. That's why we can say the string is collection of alphabet. It is denoted with W. And the length of the string is denoted with mod W. Mod W. So here we have to know about the what is symbol, what is alphabet and what is string. Symbol is nothing but it is the collection of letters, numbers, all those things. So, what is alphabet? The alphabet is a collection of symbols and it is denoted with sigma. The third one we have learned, that is string. The string is the collection of alphabet. It is denoted with W. And the length of a string is denoted with mod W. The next terminology is language. What is language? The language is set of all the strings. Set of all the strings or collection of string. Or collection of string. It is denoted with L. The main point we need to remember, that is language. How we will represent, how we will use, that is language. The set of strings between two flower brackets, it is known as a language. So it is denoted with L. And the sigma, for example, sigma is equal to A comma P. So manaki two inputs in the given the two alphabets, we need to write the language for these two alphabets, that is language is denoted with L. So already I said it is a set of a string, it is denoted with L. So possibilities A, singly undachu, because they didn't mention any length. So we can write all the possibilities in language. A comma B, AB, BA, AA, BB, BAB, AAA, and so on. So the language of the string is A, B, AA, BA, AB. So here they didn't mention any length. So we can write the string length is infinity. So it has to between A and B. So next, the clean closure. The clean closure is nothing but A. The clean closure set of all the strings. Choose over an alphabet. Choose over an alphabet. The length includes epsilon. Epsilon should be like a E, but the middle line should be a bigger than the top and down. So the set of all the strings chosen over an alphabet. Over an alphabet, and it is also a universal set, Next is the clean closure or clean positive antam దీన్ని. So this is clean positive. It will exclude the length. Suppose we have the A plus. A plus ante we can write as L is equal to A comma A related to the all the A's excluding epsilon. So here clean closure and it has to be include epsilon. That clean closure or clear sigma plus, it is set of all the strings. It will be represented with the sigma plus, and it is a universal set. It can be written as a comma comma a. The next one is finite automata model. So what is finite automata model? This finite automata model contains the three types. First one is input tape, the second one is read head type, and the third one is control state, we can say, or else we can say finite state control. So here this is the block diagram. For example, we have taken 4 A's. The string is 4 A's and 4 B's. 4 A's and 4 B's. So here the input tape, it will be insert the every element. It will be insert every element, that is A, and we have 4 B's. After completion of this, the input tape, it is known as a block. That block is divided into the cells. So each cell is insert with the single alphabet. So input, it is divided into the cells. Each cell is inserted with the one element. That is known as a input tape. So వీటిని ఏమంటాము? We can say as cells. So in these cells, this will be read by the read head state. So what is the purpose of read head? The read head is used to read the every alphabet which contains in the input tape from the left to right until the input tape completes the string. The next finite state control. So the finite state control is nothing but it is used to store all the errors which is accepted or rejected. Anything. The finite state control, it is used to store the memory, errors, all these loops, and it may be the accept, it may be the rejected by finite state control. Next is the introduction to finite automata. So this finite automata contains, it is used to recognize patterns or language. So what is the use of it? Is the finite automata is the mathematical computation. It is used to recognize pattern or languages. For it contains 5 tuples, that is Q, sigma, delta, Q naught, F. What is Q? The Q is nothing but it is a finite set, and we can say number of states. Next, sigma. Sigma is nothing but input string. Next, the transition. Delta is nothing but delta. So transition function delta. Delta is used to transfer from one state to another state. So మనం ఇక్కడ ఇచ్చిన సింబల్ దీన్ని డెల్టా అంటాం. So the Q naught is nothing but a initial state. And the F is nothing but a final state. The F is nothing but a final state. So first in this flat, we need to remember these 5 tuples to do the conversions between deterministic finite automata to non-deterministic finite automata, non-deterministic finite automata to deterministic finite automata. So we have totally how many we have the tuples? 5 tuples, that is Q, sigma, delta, Q naught and final state. So here the structural representation of automata, So first we have 2 types of structural representation. The first type is state diagram. First one is state diagram, or we can say transition diagram. The second one is transition table. So this transition diagram contains 5. It contains 5. So here the single circle we can say it will represent as a state. The single circle, it will represent as a state. So oka circle unte it will be represented as a state. So whenever the single circle, it will be marked at the starting of the state, it will known as a initial state. It is known as a initial state. Next, from one state to another state. It is going to one state to another state. By one state to another state, it is going from one state to another state by using input strings. It is known as a transition functions like A gavachu. We can say B and 0, 1. Letters and alphabets, we can say that input strings. So by using transition function from one state to another state, we are sending the input symbols. Next, the transition table. It contains rows and columns. The rows refers the states. The rows represents the states. So the above problem I am constructing the transition table. State input symbol. Row is, we have 2 states, Q naught, Q1. Q naught single circle to unnadi, we can say as a initial states and states. Arrow mark starting lo unte, that is initial state. The single circle, we can say state. So how many states we have? 2 states, Q naught, Q1, with the 0 and 1 input strings. So Q naught of 0, the transition function work enti, it is used to transfer the input symbol from one state to another state. So here we are using 0 and 1. So according to the DFA rule, for every input string or every input symbol should go through all the states. So Q naught of 0, it goes to the Q1. Q naught of 1, it goes to the self loop undi kabatti, it goes to the Q naught only. Next, Q1 of 0, we have again self loop, ante whenever it contains the self loop, it is known as a n number of symbols, and we can say it will go to the self only. So Q1 of 0, Q1, and Q1 of 1, it is going to the Q naught. So the transition table, it contains rows and columns. The rows contain state. How we can represent the state? With the single circle. The next, whenever the circle at the starting of the circle, it is represented with the arrow mark or it is recognized with the arrow mark. It is known as a initial state. And one state to another state, we are passing the input symbol. It is known as a transition function. The fourth one is final state. The final state is represented with the double circle. Represented with the double circle. So the next one is we have finite automata types. So the finite automata contains two types. One is deterministic finite automata. The second one is non-deterministic finite automata. So first today we are going to learn that what is the how to construct the DFA and how we are using the input strings. So totally the construction of DFA, it contains 5 types, that is starts with, second one ends with, third one substring, fourth one divisibility, and the fifth one is length. So to construct DFA, we have 5 types, that is starts with, ends with, substring, divisibility and length. So we have some rules for DFA. The DFA should not change as the initial state and final state. Initial state and final state. Always the initial state should be recognized with the arrow mark at the starting. And the double circle refers the final state. First one. The second rule is every state should use the both input strings. If they given 3 input strings also, it has to use 3 input strings. The input strings may be the AB. It will be represented with the sigma is equal to A comma B. Otherwise, sigma is equal to 0 comma 1. 0 comma 1. So today we are going to construct first one. Construct DFA which accepts all the strings over an alphabet. Over an alphabet. Sigma is equal to 0 comma 1. Starts with 0, 1. Starts with 0, 1. So already we discussed construction of DFA. It contains 5 steps. The first one is starts with. So today we are going to do with the starts with only. Here they given the first problem. They given the sigma is equal to 0 comma 1. The condition is given starts with 0, 1. So DFA, whenever we are discussing DFA, it has to follow the 2 rules, initial and final state. And every input string should be move from the one state to another state, and it reaches the it has to reach the every state. So first we need to find out how many states. To find out the states, the formula is n plus 1. Formula is n plus 1. So n plus 1 ante what is n? Number of variables they given. They given the variables 0 and 1. Starts with, given the condition starts with 0, 1 variables. So is 0, 1 how many digits are there? 2. So n plus 2 we need to enter 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. And how many states we have? 3 states. Q0, Q1 and Q2. Directly we can write initial state and final state. So initial state, before transition diagram, we need to write language. The condition is starts with 0, 1, 0, 1, 0, starts with 0 1 తోనే స్టార్ట్ అవ్వాలి. సో starts with 0 1 0 1 0 0 1 1 and so on. The language is 0 1 0 1 0 0 1 1. So Q0 first 0 we have 2 ante Q0 of 0 it is going to Q1. So our cursor is at Q1. So from Q1 the another digit will go to the final state. Next 0 already there, 1 already there, 0 ante we can use self loop 0. Self loop 0. Self loop 0 ante n number of zeros, but condition అనేది 0 1 తో స్టార్ట్ అవ్వాలి. 0 1 తో స్టార్ట్ అయ్యి we can use n number of zeros at the end. The next one 0 1 1. So comma 1 0 1 1 n number of ones ఉండొచ్చు, n number of zeros ఉండొచ్చు. కాబట్టి సెల్ఫ్ లూప్ 0 1 ends లో n అని ఉండొచ్చు కాబట్టి I am giving సెల్ఫ్ లూప్ 0 1. Next, so according to the condition DFA should move every input string from one state to another state. So here the Q0 uses only 0. Remaining one we can't give the self because the starts with 0 1 only. So whenever we are writing starts with, we need to use dummy state. This is dummy state. The dummy state or dead state, or we can say dummy state, dead state and empty state also. So it does not contains any value. It does not contains any value. 0 1. So already the Q0 uses the 0. So from Q0 it has to be sent 1. And the Q1 already uses the 1 kabatti we are sending 0 to the dummy state. So this is the transition diagram for starts with. Now I am doing transition table. How many states we have? Q0, Q1, Q2. 0, 1. States input symbol. Q0 of 0, Q1. Q0 of 0, Q1. Next, Q0 of 1, Q pi. Q1 of 0, Q pi. Q1 of 1, Q2. Q2 of 0, Q2. Q2 of 1, Q2. So this is the transition table. So starts with condition is 0 1. First we need to write the language and then we need to draw the transition diagram. For DFA every input string should go through the every state and it will move from it has to move from one state to another state. Whenever it can't be reached, whenever it not satisfy the condition, we use the dead state. Dead state, dummy state and empty state also. And empty state. This is the starts with. Next one is construct DFA. Construct DFA which accept all the strings. Which accept all the strings over an alphabet. Over an alphabet. Sigma is equal to A comma B. A comma B. Condition is ends with A B. Ends with A B. Before that we need to write language. L is equal to AB. Ends with అన్నారు ముందు n అన్న b's ఉండొచ్చు, n అన్న n number of a's and n number of b's, but ending matram it has to be AB. AAB, BAB and so on. So here how many states were required? How many variables? 2. So n plus 1 is equal to 2 plus 1 is equal to 3. Q0, Q1, Q2. Final state is Q2. Initial state is Q0. So first one, A. Next, B. Next element is B. First string is satisfied. Next, A, B. So ends with AB annam. So we can use self loop for the Q1. A, B. Next, B. Starting n number of B's ఉండొచ్చు. So self loop B, A, B. Next, whenever suppose ఇక్కడ మనము A, B ఇచ్చాం. Whenever we give the self loop A, B, it will be say A, B, 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 B. But condition is it has to be ends with A, A, B. So only AB to end అవ్వాలి కాబట్టి whenever ends with, we use the ends with, it has to be used backtracking. So the backtracking, I am sending A to the Q1, sending back the input symbol to the another state, that is backtracking A. Next, A, B we can send to the Q1. A, B we can send to the Q1. So, sorry, B is I am sending only A and B I am sending to the Q0. I am sending to the Q0. So, transition diagram already I said rows are states and columns are input symbols. So, thank you.